All right, everyone, let's get started. Thank you for joining us today. My name is Megan Carter, and on behalf of CloudfloorDNS and Everbridge, I'm excited to present this webinar, Concepts and Techniques for Avoiding DNS Outage Downtime. In this webinar, our presenter will discuss how DNS is a critical technology for your business, describe downtime in the DDoS and DYN attack, highlight why you should utilize a managed DNS provider, discuss SOA records and delegation, speak about secondary DNS techniques for redundancy, and lastly, review challenges with secondary DNS. After the presentation, we'll have about a 15-minute Q&A session with our speakers. Come on. There we go. As a reminder, you can submit your questions at any time during the webinar. You can send your questions by typing in the open text field in the questions panel and sending the questions to all panelists. If time runs out before your question is asked, we'll try to follow up with you after the webinar. Links to the recording and as well as slides will be available within a few days of today's session, and they'll be sent out to you as soon as possible as a follow-up. If you don't already, please feel free to check out our website, the Everbridge website and the CloudfloorDNS website, and also you can follow Everbridge on Twitter if you like. And now I'd like to introduce our speakers. Eric McIntyre is a Senior Director of DNS Business Development at CloudfloorDNS with focus on enterprise DNS sales and marketing. He has over 20 years of experience in the domain and DNS industry and has worn many hats as the co-founder of TZO.com, a managed DNS business that he sold to DYN in 2012. He started his career doing tech support for a small software company and also held several positions at Lotus Development back in the early 90s. Eric holds a Bachelor of Business Administration from Plymouth State College and enjoys tinkering with his Z-Wave automated home, so cool, and enjoys live music, snowmobiling, and slalom water skiing in his time off. Jeff is a Senior Director of DNS Network Engineering and Operations at CloudfloorDNS with focus on system and network engineering. He has been in the domain and DNS industry for 17 years and has held many positions doing what he loves. Jeff has spent a lot of time in data centers looking at UDP packets, adjusting Anycast networks, and managing many different systems, networks, and platforms. He started his computer career with a medium-sized Australian-based company with a remote office based in the United States, where he administered their systems and networks in a new office build-out. From there, he went on to TZO and scaled their infrastructure to an enterprise-class service, which was acquired by DYN Inc. In 2012. While at DYN, Jeff led the operations for a new data center deployment in Mumbai, India, which decreased DNS latency approximately 200 milliseconds in the country. Jeff enjoys spending his time on the open ocean in the summer, at swim meets with his family during the winter, and studying martial arts. We're excited to have both Eric and Jeff with us today. And now I'm going to turn it over to Eric. Eric, you should be getting a presentation. There you go.
So thank you, everybody, for your patience. Again, my name is Eric, and I'm here to talk to you a little bit about DNS and secondary DNS. So I first want to start out in talking a little bit about why DNS is so important. To explain it, I like to use simple analogies that kind of help you understand the critical nature of it. So if you think about registering a domain name, imagine that as your plot of land, like you're going to build a house. And you obviously can't build a house without having a plot of land. And once you buy that domain name you get your land, you need to build a foundation for your house. And so this is kind of like your internet house, right? Your house of business. So once you have your domain, you build your foundation. The foundation is what holds everything else up, all the other technologies that you rely on to operate your online business. So here you'll see that the mail server is up near the peak, the web servers, the door, those are components that allow your house to live. and then there's your services that are in the house, so to speak. So imagine if all of a sudden you forgot to renew your domain name. It's almost like a sinkhole, right? The land goes down in, there goes your DNS, and there goes all your related services from your business all down the tubes. So you can see that the DNS is really the next most critical, important piece of technology in the chain when it comes to having an online business. You guys see that? That's weird. I don't know why this isn't working. Just bear with me, people. We're having some slide issues here. All right, hold on. I'm going to change my screen. Just bear with us 1 second, people. We're going to go ahead and very odd. All right, I'm going to kill this real quick. Okay, can you guys see that now?
Yes.
All right. Now, there we go. Okay, so what we want to do is talk a little bit about why it's important to invest in your infrastructure. Specifically your authoritative DNS infrastructure. There are two main types of DNS servers. There's recursive, and then there's the resolver. So the recursive, resolver, and authoritative. So CloudfloorDNS is an authoritative server. We answer requests based on the recursive and resolvers asking where a certain resource or domain name or component of a domain name resides. So when you're sitting at home and you're browsing or you're at work, your recursive server would be either your work DNS server that does all the heavy lifting, asking where Google is, asking where example.com is, etc., or it could be your ISP server. Charter, Time Warner, Comcast, etc., has recursive servers that run within their network to serve their customers to answer and obtain these queries. So again, Cloudfloor does authoritative, and the important part of authoritative is it's involved in every transaction online. Every web page lookup, everything that you do, every email it's sent is all answered by authoritative DNS, and recursive DNS fetches that information from authoritative and sends it back to the user. So due to the fact that there could be up to 200 to 300 DNS requests just to build a simple web page, it's very critical that your DNS is very fast. If you do not have fast DNS or it's very slow, you're going to get slow apps and slow websites. And slow websites and apps mean loss of sales, loss of customers, customer satisfaction, shopping cart abandonment, etc. So there's a trickle-down effect to having slow apps and websites that your customers expect. So, another reason to invest in authoritative DNS is authoritative DNS is very flexible. Not only does it serve your requests for your domain, but you can also utilize it very quickly for load balancing. You can use DNS failover, GeoDNS, server monitoring. There's a lot of things that managed DNS providers can give you. So DDoS attacks are also another reason you want to invest. Everyone knows that DDoS attacks are really bad, and they're not only on the increase, but they're actually getting much larger in size, and they're an extreme danger to your online operations. And then lastly, DNS has a great return on investment. It instantly speeds up and protects your operations, and there's virtually an immediate positive impact on almost every online resource using that DNS. So DDoS attacks are on the rise, as I alluded to earlier. According to Akamai, DDoS attacks increased 71% over Q3 2015, and 19 total attacks peaked out at over 100 gigabits a second. And this was done from a report on Q3 in 2016. So the Dyn attack was an attack on Dyn itself as a managed DNS provider. It wasn't attacking a subset of customers, it was attacking Dyn itself. And this attack was a very large attack using tens of millions of IPs from compromised devices, as well as other methods, mainly the Mirai botnet. So VeriSign also reported over 81% of the attacks peaked at 1 gigabits a second, and the attack size is 82% greater than last year. So there's definitely a significant increase in DDoS attacks and their threat. And then VeriSign also reported that 37% of all the attacks were aimed at IT, cloud, and SaaS services. And that's the highest percentage within a certain vertical. Other industries are banking and online media, et cetera. But definitely IT, cloud, and SaaS services seem to be a major target. So now we'll talk a little bit about the attack on Dyn. So as Megan alluded to earlier, Jeff and I had sold our last company, TZO, to Dyn and worked there for a little while. Dyn is a very large and reputable managed DNS provider, and they were attacked directly. This was a multi-vector attack, a multiple method attack, and involved tens of millions of IPs. Some were from Mirai. It's very difficult to truly drill down to exactly what it was, but it seemed like the Mirai botnet, which was a kind of a botnet of compromised devices, IoT devices, internet cameras, DVRs, et cetera, that were used in that attack. And the attack severely degraded the Dyn network. Some sites were extremely slow that were on the network, some were unavailable, and some were almost unaffected, but the majority of their network in the U.S. and East Coast, West Coast, throughout continental U.S. was affected greatly, which of course affected a lot of other people around the world. So part of the sites that were affected, includes Netflix, HostGator, GitHub, Etsy, Amazon, DirecTV, Shopify, Twitter, Wall Street Journal, and many others. There's a very large list of affected sites. And as I said before, much of the U.S. was affected. East Coast was affected first early in the morning, and then there was the West Coast hit, and it was in multiple waves and lasted several hours. So one of the reasons you want to protect yourself is attacks and downtime are extremely, extremely expensive for online operations. The Fortune 1000, due to an IDC study in late 2015, said the cost of downtime, the average cost of downtime, can be upwards of $100,000 per hour for a Fortune 1000. That's probably closer to $150,000 now, just due to the fact of all the online operations and the reliance on these. It definitely has a loss of sales, a loss of customers and prospects. They can't shop. APIs, apps don't work, and there's extensive brand damage, and it trickles down across the brand to your sales. So it's not only just a loss of sales, it continues to trickle down throughout your organization. And of course, attacks are also sometimes based on ransom. There's DDoS attacks that will hit you, then they'll ask you to pay a ransom. If you don't pay, they'll go ahead and attack you again. And these mini attacks just kind of show that they're a threat, and then they'll try to extort money out of you. So one of the reasons you would want to switch to a managed Anycast DNS is because managed DNS providers pretty much utilize a very large network, and they serve your authoritative DNS. One of the real main reasons to choose a managed Anycast DNS provider is because they often have a strong technological focus just on that, authoritative DNS only. If, let's say, you choose to go with GoDaddy or your web host and say, hey, you know what, it's good enough, it's working, there's definitely some inherent issues there. They may not focus on their DNS network. It's almost like they have to have that just to sell you a website and sell you email hosting. They have to have DNS. So it's an afterthought. It's something that's not the focus of that business, and there can be issues with that. Anycast DNS is definitely faster, and it's much more resilient than traditional unicast DNS. And that's due to the fact that it pretty much mirrors the same IP address throughout the world, and with routing, essentially you get to the closest server or the fastest server, and which just simply speeds up operations. Most managed DNS providers also offer advanced DNS, such as GeoDNS or load balancing, You can also do the DNS failover and other unique aspects of being able to utilize these services on DNS without having to go out and find another vendor or hardware provider at each location to do these types of things. Since DNS is involved in everything, it's really a great way to do your load balancing and your other advanced services within the DNS itself. And then, of course, one other benefit is the SLA. You get a service level agreement for the most part on most managed Anycast DNS provider. They'll give you an SLA for 100% uptime, and they'll also give you typically a performance SLA, which guarantees you a certain millisecond performance time on their servers when someone's requesting your domain. So you definitely want to think about a secondary DNS. Obviously, the Dyn attack got a lot of people thinking about, how can I prevent something like this from actually happening? So what we want to do is add a second provider into the mix. And this is just a great way to protect yourself and your business. So really, secondary just simply mirrors your DNS onto a separate network, and it can automatically sync using DNS technology such as AXFR, notify, manual sync via API. And there's also the statement of authority and zone records get updated as well to show who's going to answer for this particular record, such as example.com. So secondary DNS also really extends your global presence. So it basically adds you onto a whole nother network, and it's not just one server, it's a massive network of DNS servers. So let's say you were using Dyn as your primary provider, you can add in Cloudfloor as a secondary DNS, and it will add in our network as well. So your resiliency is that much larger, and your opportunity to mitigate DDoS attacks means you have that much more network to absorb that. So for secondary, there are multiple methods you can utilize. One's known as hidden master. There's also traditional secondary. There's dark secondary, or you can do dual primary. It's not necessarily secondary DNS, but it is a way of extending the resiliency of your DNS and mirroring it on a separate network. And then, of course, secondary DNS really is a low-cost DNS insurance, and it protects your online investment. So here's a little chart to show you a little bit about how the whole chain of DNS works. So as I alluded to before, you've got your recursive DNS in the upper left, and that's your DNS at your ISP or your DNS at work, or it could be Google Public DNS or Open DNS, any one of the recursive DNS providers out there, or your ISP. And in the bottom left, you have your client or browser. And that's actually doing the requesting for example.com in this case. So you can see that the arrow 1 goes up to recursive. It says, hey, do you know what this is? Before it'll actually go up to this number 1 arrow to the recursive, it'll actually check its local cache to see if maybe example.com might be already on the machine in the local browser cache. Maybe you went there yesterday, you went there an hour before that, and depending on how long that record is set to time out, the machine will try to save time by pulling that request out of the browser itself. If it's not in the browser cache, it's going to ask the recursive server. If the recursive server says, hey, you know what, I have a copy of this that someone just requested on my network 10 minutes ago, and it's still within the TTL or cache timeout, it will send and deliver that to the client and say, go here. If it doesn't have it, the next step is the recursive server will go up on arrow 2 and talk to the root and say, hey, I have somebody requesting a domain in the .com namespace, and it happens to be example.com. The name server will send back a request to recursive. Recursive will then go to the .com namespace, ask who has the authority for example.com. That again goes back to recursive. Then it goes to example.com, which is actually on the CloudfloorDNS servers. Okay, so this isn't just one server here. This is a multiple set of a network of servers. It'll ask where www.example.com is, since that's what I'm looking for, and it will send that back to recursive. And then finally, the recursive server will deliver that in step 8 back to the local client, and then of course the local client will connect to that resource directly. So you can see there's a multitude of different queries and lookups and information back and forth. And it's critical that step 6 and 7 is ultra fast, because typically 2, 3, 4, and 5 are very fast. Those are extremely fast servers with very large networks that should never, ever, ever go down because they're TLD servers and root servers. So the faster you answer that back, the faster a customer can render the web page, get to the cart, add something in, and check out, overall increasing your sales. And they've found that typically 100 millisecond, I think it was Amazon that did this study, 100 milliseconds or more delay will drop at least 1% in sales. So that's a significant thing to think about. It's not only reliability, but it's also the speed. So part of what makes all the recursive servers find out where example.com is about the authority, the SOA, the Statement of Authority record. So this SOA record lives within a DNS zone, and it's part of the zone file, and it pretty much tells who the master authoritative DNS is. It could be, hey, I'm hosted at Cloudflore, it's hosted at CloudfloorDNS. It could be hosted at both, and it will hand back the list of those servers that is responsible for kicking that off. At least it will hand back the master server that will then hand back that list. So the SOA has a TTL, or time to live, or a cache time, and it also includes a serial number and some other data. And when that serial number is incremented, it can kick off a zone update. And this is known as a XFR or AXFR, IXFR update, and the notify is what can kick that off. The domain name zone file includes NS records. Those are considered name server records. So not only would you need to possibly make a change in the SOA and the TTL to lower that, but also the domain name and the NS records, you want to make sure that if you have a secondary provider, you have NS records for Dyn, and you also have NS records for CloudfloorDNS, or you have NS records for UltraDNS and Cloudflore, or GoDaddy and Cloudflore. So it's important that you follow those 3 steps, and we also have documents on our site that can walk you through these things. So once you've set the statement of authority up and you've mirrored your zone, it's all in the delegation. And the delegation primarily says what name servers you can ask for this data. So it gives you the list of the name servers where the domain resides. So in this case, we have example.com at GoDaddy Premium on their Premium DNS. And this is what your delegation would look like. If you do a dig, NS, and this shows example.com short, it will pull down, those are the 2 servers that can be queried to find out any of the resources where example.com lives. So here's a delegation with secondary DNS. So now when I do a dig on example.com, I've delegated not only to domain control or GoDaddy, but I've also delegated to some of the Anycast network on CloudfloorDNS. So now you can see PO8 and PO9 from the domain control servers are in the network, and now you also see 4 CloudfloorDNS servers also split across multiple TLDs for additional redundancy. So here's an example of what would happen when you actually add secondary DNS to your delegation. So you get it all set up and mirrored, and then what you would do is you would add in the Dyn name servers here. Let's say Dyn is primary. We added in Cloudflore as a secondary. So now you've got all the same discussions going on between recursive and everything else. Oops, I'm sorry about that. You have the same information going on back and forth, but here on step 6 and 7, it could hit any one of the name servers within the Dyn space or the CloudfloorDNS space. If there is an issue with Dyn or Cloudflore, the servers that aren't degraded will pick up the slack and will always be up and running if other parts of that network are down or the other provider is down. So it's really a really simple way of extending the reliability across multiple providers. You can even add 3 or 4 additional providers, so you have a large tertiary network as well. So there's definitely a lot better reliability here when you do it in this method. So again, we're going to talk a little bit about basic secondary. Before you can do secondary DNS, you need to make sure that your host offers XFR or AXFR or IXFR zone transfers. And that's just simply a protocol that will transfer a zone, a DNS zone file from one server to a slave, a master to a slave, etc. Amazon currently does not offer XFR. The majority of other managed DNS providers out there will offer this. So Dyn, Ultra, NS1, Cloudflore, there's a lot of other providers out there as well. But they have to have XFR. So if you're using GoDaddy Basic, just domain control and not the premium, there's no secondary DNS options available to you. You have to upgrade to the premium service, and then you have XFR options available, and you can actually sync your DNS with somebody else. So master DNS allows the XFR transfers from the slave or secondary IPs. So when you first set this up, the secondary DNS is granted permission from the primary to actually go in and request the zone transfer from the master example.com server. The master then sends the DNS zone data to the secondary or slave, and then changes on the master are synced to the secondary automatically or manual via API. And then basically two different networks are serving your zone, not only enhancing redundancy, but it provides much more resiliency during attacks and outages, and can also speed up your network depending on who you choose for a provider. So here's the setup with the standard secondary. And again, here we show the two namespaces with Dyn and Cloudflore as secondary. And here's a little bit of information about the hidden master. So the hidden master is an option. It depends whether you have it in delegated or not. If it's not in the delegation, let's say Example Corp has their own DNS server that they've been running forever. They have two different, or DNS network, I should say. They have, an external host location, and their sysadmins have always been updating those bind servers when they make changes. Now they're they went public, or they're getting large, and they've had an attack, and they really want to kind of add resiliency to their DNS network, but they also want to continue to make changes on their own DNS. So what we can do is do a thing called the hidden master. And what the hidden master does is kind of keeping the example.com DNS servers out of the delegation, but they're still the master. Okay, so the sysadmins still make changes on that DNS, and then what happens is instead of them answering requests, they're only making changes, and that change then gets synced externally to the secondary and tertiary provider. So the master is hidden and not delegating or answering, but it is responsible for holding all the records and is the master of that zone file. So any changes you make, you do it normally as you usually did, boom, and then you can either update every XX minutes, we will do an automatic pull every 30 minutes, or you can use the API to force. And then setup is really, really, really simple. We did a bunch of documents on how to do secondary DNS with GoDaddy, NS1, and Dyn, and literally within about 10 minutes is all it takes to mirror your zone, get everything set up, and adding that redundancy. So it's very, very simple, quick, and easy. So here again is the setup with the hidden master secondary, okay? So you can see here in the blue circle that example.com name servers, they're in the corporation, at least run by the corporation, but they're not in the delegation. So Cloudflore would do all the heavy lifting, and if you decided to, or let's say that Cloudflore had some issue, or maybe it was degraded, you could add your name servers into the delegation, and you'd have both of us answering, or you could add a secondary and tertiary that would still give you a true secondary reliable DNS between, let's say, Cloudflore and NS1, but yet allow you to run the master on your own network without having to have it answer. So again, and here's kind of the setup with the hidden master, adding literally a tertiary or another secondary provider. So you can see here again, here's the hidden master, and there's example.com running on Cloudflore and example.com running on NS1, both simultaneously, and one will pick up the slack for the other if there's an issue. So this is the dark secondary. So dark secondary is pretty much a way of having secondary DNS synced, but not in the delegation. So some customers might want to do this if they're very comfortable running their own server, they're very satisfied, but they want that little insurance on the side in case there's a problem. They can change the delegation and delegate the answer and authority over to Cloudfloor if their servers are degraded or having an issue. So it's not, again, the secondary is not put in the delegation, but we are synchronizing, and we're kind of sitting in the back waiting. And until there's an outage or an attack, there's no delegation. And oftentimes companies will do the dark secondary because sometimes advanced services like failover, GeoDNS, and other services aren't necessarily mapped one-to-one. So Dyn does it one way, we do it another way. We both get to the same resource in different ways, but it's still the same resource. So that would allow you to take your primary DNS with Dyn and then mirror it over, which only mirrors the core DNS records, then log into Cloudfloor and add your advanced records, but it's sitting there, and then what you would do is you'd only mirror the records as they come across, and as soon as there's an attack, you can basically go up and change the SOA and add us into the delegation, and then we'll start answering when that company has some issues. So, and again, the SOA record is updated to reflect the new authority, and you typically want a low TTL on that to help flush that out quicker. And a TTL is the cache times to say, hey, start to check, and there might be a new authoritative server in the mix. And then again, secondary takes over as primary while the former primary is down. And then here again is the setup with the dark secondary. So let's say that example.com has their primary DNS with Dyn. This would set up an initial XFR transfer. We transfer all the records. We stop the transfer and convert this one to a primary. And then what we do is add the additional records so it's apples to apples comparison, but we don't delegate to Cloudfloor until there's an issue. And then we can bring them into the delegation if there's ever a degradation or another attack at Dyn. And then, of course, there is secondary and or dual primary. And what this does is very, very similar to the dark secondary, but you actually initially sync with a secondary XFR, you convert it to primary, then you make sure you add in all the advanced DNS records, because each provider handles them separately. You manually process any other new record changes since that happens, because if you synchronize again, pretty much all the records will get overwritten, because synchronization only pulls core DNS records in. Doesn't do failover, it doesn't do load balancing in some cases, and it definitely won't do GeoDNS. And if it does, it won't necessarily map them apples to apples depending on the two providers. And then really once both providers are listed within the delegation, now you've got both providers chugging away and you have an extremely resilient network in case there's an attack. And then again, here's the setup for dual primary. So the only thing different between this and a secondary is there really is no XFR, and there's no synchronization between the two DNS providers. It's just apples to apples. You make sure that everything's the same on both, or at least everything gets to the same resource and the same methodology. And that's it. And then when you add new records on Dyn, because since that's the primary, or they're really dual primaries, you want to add the same record over at Cloudfloor. And you can either do that with an API if it's a standard record, or you could just go in manually and add that in and save it. And you want to try to do those things simultaneously or very close to simultaneously, because you don't want to have one mixing and sending a different IP and the other, and that could definitely cause some problems in the recursive as well as within your browser. You might get different really shady results. So how does secondary pick up the slack when a failure occurs? Many recursives use RTT, or round trip time. And what this does is this is kind of a stopwatch that really identifies the fastest name servers that are in the delegation, and then simply sends a request to that server or servers. It typically caches and then periodically tests others and determines, okay, this one's faster now, I'm going to start sending more to this. And really, there's a lot of servers out there that use RTT banding, but recently it's not really the best method, and primarily it's because anycast DNS technologies, you might go to a server that's not necessarily closest to you and faster, or it could be faster but not closest. So it's really, anycast really is one of those technologies that helps. You don't have to use RTT banding, and we're seeing less and less of that because it doesn't really work that well with anycast. And then the same thing with GeoDNS. So it's about 80% of the recursive servers now, we still utilize RTT banding, but there are definitely some newer servers out there that don't, that may or may not work better. And just due to the whole nature of DNS, nature of networks, where you are, what type of connection you're on, none of this is exact science. It's it depends on where you are in the world, what time of day, and again, what type of connection, who's hitting the servers. DNS is a very fluctuating technology, but it is one of those things where you can provide the fastest speed and typically get really, really, really close to that speed all the time, but it will fluctuate here and there. And then, lastly, what we want to do is talk a little bit about some of the challenges. And I think I've alluded to those already, is that not all the managed DNS providers out there offer secondary DNS XFR, but not all of them also have services that act the same. Yeah, we all have MX records and CNAME records and A records. They're all standard DNS technology, and XFR works fine with those. But once you start adding GeoDNS, we do it a little bit different than NS1, and NS1 does it a little bit different than DYNE. And you can't expect an apples-to-apples synchronization. So it does take a little bit of tweaking and understanding and working with the systems engineers at Cloudflare or the other managed DNS provider, and then working together to find out the best possible method to implement this. And of course, we'll work with you to make sure and truly get a copy of your zone and really understand what records we might need to manipulate in a different way. Now, the other thing is the ACLs protect the XFR of transfers of domains. So you need to make sure that the IPs of the slaves have access to the zone, can pull from the masters. And that's something that's pretty standard when you set up XFR or set up secondary on any managed DNS provider. They're going to ask you the host names or the IPs of the slaves, so then they can add that into the access control list for that particular zone and say, okay, if anybody's asking to do XFR, for example, .com, these IPs at Cloudflare are allowed to pull that data from DYNE. And then if you're using a dual primary, like I said, it's a little bit more manual, and then you can use the API or a manual process to sync up your records on both providers. And then, of course, DNSSEC records can also prove to be tricky with secondary DNS, depending whether you use that or not. So we're wrapping up near the end, and what I want to do is just kind of give you guys a little bit of some information here on the secondary DNS resources. So these resources here these are some of the how-tos, and if you click on these Adobe PDF links, these will bring you directly to the PDF page on our secondary DNS, on our secondary DNS services page. So what these will do is these will just kind of show you step by step. If you're using NS1 as your primary and you want to add a secondary with Cloudflare, that shows you how to do it step by step. Same thing with DYNE and same thing with GoDaddy. We'll be adding DNS Made Easy and a few others soon. And we also ask that you follow us on Twitter at CloudfloorDNS, and you like us on Facebook. All right, so what I'm going to do now is I'm going to hand over the question and answers to Jeff Cronstrom. And again, he's the Senior Director of DNS Operations and Engineering for CloudfloorDNS. And our emails are also on here if you want to send an email to us and ask any questions, or you can visit our website and submit any one of the forms there for questions as well.
Yeah, just some housekeeping. So we already have some questions right now that came in from the audience, but if you do want to submit a question, just type in the question into the open text field in the questions panel and submit it to all panelists, and we'll answer as many questions as we can get to. All right, so the first question is asking, is about cache, and we talked about that earlier in the webinar, but it's asking if resolvers normally cache DNS lookups.
Yes, the answer to that is yes, they do. They cache the DNS lookups for whatever the TTL or the cache time, whatever that is set to for that particular record.
Excellent. So actually, you're just talking about TTL, and we did get a question asking what the recommended TTL time was for DNS.
Well, the recommended TTL is different for different types of records and what you're doing with those records. So, for instance, if you're doing load balancing across a particular record, you may want to set the TTL to 30 seconds, something very low, so in case one of those load balancing hosts goes down, it needs to be removed from the load balancing set. It will happen very quickly. Also, say, for instance, if you've got a couple of MX records in a particular zone, and those are static, you might want to set those higher, say, to a 3600 or an hour or so. So it all depends on the record type.
Okay, great. The next question is asking about primary and secondary. And the question is, would you support having Cloudfloor as the primary and another DNS provider as the secondary?
Yes, absolutely. So other providers can do zone transfers out of Cloudfloor, so we can act as a primary and others can be secondaries.
Excellent. Okay, so the next question is asking if the authoritative DNS servers are the same as the recursive servers used by customers, wouldn't that be the fastest way to resolve DNS?
You really don't want to mix up recursive servers and authoritative servers. They do two different functions, and they should be independent of each other. It's best when the authoritative servers sit very close to the recursive servers, then you'll get the fastest service possible. But you really don't want to mix those two, because you can end up with cache poisoning.
The next question is asking whether or not Cloudfloor has DNS servers in Alaska.
Well, actually, we do not have any DNS servers in Alaska. We've never actually researched any data centers up there. And I think probably the closest we come to Alaska would be LA right now. And I know there are some pretty fast connections from LA to Alaska.
Okay, the next question is, does Cloudfloor also do SPF records?
Well, we do SPF, but the SPF record is actually not really used anymore. The SPF is inside of the text record, so we support SPF within the text record.
All right, and the last question that we got was, does authoritative DNS allow GeoDNS?
Yes, on our platform we do have GeoDNS, and we've got country-based geographic DNS that you can select per host on our platform. We also do geo-URL forwarding, so if somebody wants to redirect a particular host to a particular URL, we can do that as well.
All right. Okay, great. So that is all of our questions. And I'd like to thank both of you guys for such a great session. And thank you to all of our attendees who were able to join us today. If you missed any part of the webinar, please look for an email with the link to the recording in the next coming days. Eric, you mentioned putting something on YouTube as well. So, and for anyone interested in learning more, please feel free to reach out to Eric or Jess. And thank you again for your participation.
Thank you, everybody. Appreciate it.
Thank you.
Okay.
Thank you,
Megan.
Oh, yeah. Have a great day.
Thank you.